All right, so let's finish up this 6-1. We're still talking about quadrilaterals. A whole chapter we're talking about quadrilaterals, but now we're going to do something specific with several different types of quadrilaterals. So first thing we're going to do is this. I'm going to explain the little theorem. It's called as you see right here, the name of this second part of this lesson is the quadrilateral angle sum theorem. So let's break that down and see what that all means. What does that mean? Quadrilateral. So what do we know is a quadrilateral? Four-sided figure. Good. Okay. You know what angle means, but what does it mean angle sum? If I was going to take the sum of the angles, what am I doing to those angles? I'm adding them up. That's right. And it's a theorem. And a theorem can be what? Remember we talked about a difference between a postulate and a theorem. Postulates cannot be this, and then theorems can be this. Anybody remember? Proven. That's right. Okay. And we're not going to prove it, but we are going to do something that's pretty close to proving it and just kind of showing you where we get this this theorem. All right. And it should hopefully make sense. First of all, let's just draw this. Since we're talking about angle sums, we're talking about what all the angles add up to be. All right. So here's a triangle. So tell me what you know about the angle sum of a triangle. They add up to 180. Exactly right. So all three of these angles add up to 180. So we'll say this. The sum is equal to 180 degrees. Or let's be more specific, the angle sum. Everybody understand that? Means you add up all the angles and they add up to 180 degrees. All right. So we did a triangle. So guess what we're going to do now? Quadrilateral. Very good. Not much of a stretch, is it? Because that's our chapter. I'm just going to draw some funky looking quadrilateral. It's not anything real specific. It's not necessarily like a trapezoid or a parallelogram or anything like that. It's rectangle, square. It's just some basic everyday four-sided figure. None of the sides are parallel to each other. Right? So it's just a regular quadrilateral, just to show you that this works with any quadrilateral. It doesn't have to be a specific type, like a parallelogram or a rectangle or a square or anything like that. So what I'm going to do is this. Well, here's what I want to try to figure out. I want to figure out, and you probably know this already. This is almost common knowledge. If I walked outside these walls and I walked on the street somewhere and I asked them, not everybody's going to get this. Probably few people will get this, but they should. If I ask them, what do all the angles of a quadrilateral add up to be? They might take a guess and they might get it right. What do you think might be true? Four-sided figure. Any four-sided figure, all the angles add up to the same thing. 360. Very good. See, you did know it. All right, without me even showing you how. But if I asked you to tell me why that's true, that might be a little bit tougher. So let me just show you a quick example. What I'm going to do is take this, just do this in a different color. I'm going to take this quadrilateral. I'm going to split it. I'm going to take it from this vertex to this vertex over here. Why that one? Because that one's not the one that's next to that vertex. All right, this is one that's opposite. That's important because we're going to talk about this a little bit more. So what have I done? I've divided this quadrilateral into two what? Look at this thing on top. Look at this thing, say it. Triangles, exactly right. So I've got one triangle right here. Would you agree? All right, and I've got a second triangle down here. So now, again, what are we trying to do? We're trying to find out the angles, the sum of the angles of this quadrilateral. So I know the angles, I know the sum of the angles of this triangle. How many degrees is that? 180 degrees, okay? So all three of these angles, this one, and this one, add up to 180 degrees. What are the sum of the angles of the second triangle? 180 degrees. So tell me something about the sum of all the angles. What would they be? 360, that's right. All right. So the angle sum of a what? What kind of figure? Quadrilateral is equal to what? 360 degrees. All right. Think about a rectangle. A rectangle is a lot easier to see. All right. A rectangle, what do we know about all four angles of a rectangle? They're right angles. And so that must mean there are how many degrees? 90 degrees. So how many angles are there? If that's a right angle, that one, 9 times what? 9 times 4 is 360, okay? But that's not always, it's not just because it's a rectangle. It's because it's a quadrilateral. Like I could take this shape and I could, let's see, I wonder what this does. This is basically, yeah, that's not what I want. Let's go to transform and let's, I don't know, just take it like 30 degrees. Now that is not a rectangle, so I don't have 90 degrees in here, but what's still true about all 4 angles? They all do what? They still add up to 360 degrees. Everybody with me on that? All right. Because look, that one got less than 90, didn't it? But that kind of compensated for it, didn't it? All right, that was more than 90. Okay, same thing with this and this. You get the idea? So it's still 360 degrees, even though we have obtuse angles in here and we have acute, but they all balance out to each other to all add up to 360 degrees. Okay, now what I want you to see, let's do one more picture. Well, we'll probably do 2 more pictures. Let's do this. Actually, let's go to here and let's not do that because I was going to go and actually make a shape and make it a 5-sided figure, but this program makes that 5-sided figure like all equal sides and angles and stuff like that. Let's just draw 5-sided figures. So there, and again, is just random 5-sided figure. It doesn't have to look like the Pentagon down in Washington, D.C. That would be a regular Pentagon. We're not going to draw that. So I got 1, 2, 3, and then what? I got 4, and then I've got 5. Okay? All right, it doesn't have to be a regular Pentagon, just any 5-sided figure. It doesn't matter what the shape of it looks like, okay? They do have to be this, though, okay? I didn't say this. They all have to be convex. To do what we're doing right here, they all have to be convex quadrilaterals, all right? So if they're concave, that's a different story. All the angles do not add up to 360. All right, it has to be a convex quadrilateral. I left that out. All right, so what we're going to do is kind of what we did up here. Let's use the same color. We're going to pick any vertex. I don't care which vertex. Let's pick this one right here. What we're going to do is we're going to draw a vertex or a thing called a diagonal. A diagonal goes from a vertex, listen to the word, to a non-consecutive vertex. Non-consecutive. Consecutive means the ones that are right next to each other. This one is the non-consecutive. So can I draw it like these two? See these angles right here and right here? They would be consecutive angles, okay, consecutive vertices. All right, so I'm not going to draw a line from this vertex to this one right here. I'm also not going to draw it to here, okay? Where am I going to draw my diagonal, my line? From here across from it, exactly right. Now, I can also draw another diagonal, can I? From that same vertex. Okay, we're starting at the same vertex, all right? I can also draw another diagonal right here. Now, that's pretty important. How many diagonals did I have when I had a... let's not say this. How many triangles did I have when I had this quadrilateral? How many triangles did I have formed here? 2 of them. Okay, how many triangles did I have formed on a pentagon? 3, all right? Now we're going to do one more, and you're going to see kind of a, what's the word? It's a simple little word. A pattern, okay? You're going to see a pattern developing here. So how many triangles do we have here? We said it already. 1, 2, 3. So this has 180, this has 180, and this has 180. How can I find the sum of all the angles of the pentagon, the whole entire thing? Instead of going 180 plus 180 plus 180, what am I going to do? What's an easier math thing to do? Just times it by 3, exactly right. So I go 3 times 180. So 3 times 180 is 540 degrees. So the question is, what is the sum of the angles of a pentagon? What are they? Or what is it? 540 degrees, okay? So if I add up all 5 of these angles, this one, I'm just going to put one arc for each. It doesn't mean they're all equal to each other. I'm just marking the angles. So if I take this angle, this one, this one, this one, and this one, all 5 of them, what are they going to add up to be? They're all going to add up to be 540 degrees. We can do that. We can figure out the sum of the angles of any convex polygon. right? Any one, it doesn't matter. I could have 4 sides, 5 sides, 6 sides, 7, 8, 9, 10, 1,000, a million. All right, we could find, excuse me, the sum of the angles of any convex polygon. Let's do one more. We'll draw one more, I'll say that, okay, because we are going to do a little bit more than that. So let's draw a hexagon. So there's one. Again, I'm just going to draw just any kind of crazy looking thing. 1, 2, 3. Oops. And then 4. Let's make it really weird. And then 5. Well, I was going to go like this, but I can't do that because then it would be what kind of a polygon? I would be concave, right? So it's got to be convex. So I'll just go to here, and then I'll go to here. Is that 6 sides? Yep. 1, 2, 3, 4, 5, 6. Yep. So what's my little plan of attack here? I start at one vertex. It doesn't matter what vertex you start at. It doesn't make any difference. All right. Let's say I'm going to start at this one right here. Okay. I want to draw a diagonal to all the non-consecutive vertices. Does that mean I go to here? Nope. I go across it. Okay. It's a good way. Geo said across, so that's what we'll say. All right. So I go across it. So I go from here to here. That's a vertex. All right. I go from that same vertex to here. And I could have picked any of these vertices. It didn't matter which one I picked. All right. You'll still end up with the same thing. And then from that vertex, where? I got one more, don't I? Right there. Can I draw any more diagonals? No, I can't draw any more diagonals from that vertex. From that one particular vertex, I can't draw any more diagonals. That's right. I got 4 triangles. That's the next question. So I've got one triangle here. I've got a second one here, third one here, and a fourth one right here. So what's the math? What do I do to figure out the sum of all the angles of this 6-sided or hexagon? What do I do? That's it. Multiply 180 times 4, or 4 times 180. All right? And that is 720. All right? So the angle sum of a hexagon or a 6-sided figure. Again, it doesn't have to be a regular one. There's nothing special about it. It's just 6 sides. It's convex, and it's a 6-sided polygon. All right? The sum of all the angles will always be 720 degrees. It doesn't matter how I shape this hexagon. The angle sum is always going to be 720. Make sense? All right? We are going to talk about a regular polygon in a few minutes, okay? So we will do a regular polygon here in a second, but I wanted you to see this. All right, let's remember this. You got this all in your notes, okay? I'm going to scooch up a little bit so you don't see it. But let's try to figure out what our pattern is. Remember I said we were going to find a pattern? So let's write it like this. So when I had one triangle, okay, what were the sum of all the angles? It was 180, because there was only one triangle times 180, correct? Yes, you are. So one triangle is 180 degrees, okay? And that's, I'll just draw a triangle. It's kind of obvious, but a triangle has one triangle, all right? But here's what I'm going to do. A quadrilateral, again, what am I doing to that quadrilateral? I'm starting at a vertex, and I'm drawing all the what? What were those pink lines? Diagonals, right? So I drew a diagonal with a quadrilateral. How many triangles did that give me? Okay, so you know what I should do? Let's scooch this over. I got to add one more thing to this just to kind of see the pattern. And you may see the pattern already, but I'm just going to write it out for you. So actually, I already wrote it right here. Oh, I know what I want to do. 3 sides, okay? A triangle has 3 sides. How many triangles do I get out of it? I get one triangle, okay? Quadrilateral has what? 4 sides. Now, drawing a diagonal from a vertex, how many triangles am I going to get out of that? I'm going to get 2 triangles, and so what is that? It's 2 times 180. Make sense? All right. And now, a pentagon. Okay, so a pentagon has what? 5 sides. And how many triangles do I have? 3 triangles. Okay, I'm just starting to see a pattern here. Okay, let's see if it works on the next one. So how many triangles? That's 3 times what? 180, and that's 540. All right, let's do the next one. Pentagon, and then what's the next one? Hexagon, right? So a hexagon has 6 sides. How many triangles did I get out of that when I made a hexagon? 4 triangles, okay? And then that's what? 4 times 180, and that is 720. Now, I haven't drawn this, okay, but what's the next one? Heptagon, or what do we call it? Septagon? Yeah. Some books use the prefix hepta, I believe, for a 7. All right, but I think we use septa in here. So how many sides is that? 7 sides. Now, let's use our pattern. What do you think, how many triangles will you get if I take a 7-sided convex polygon, all right, and I drew diagonals from one vertex to non-consecutive vertices? Man, that's a mouthful, isn't it? But you understand what I said, don't you now? All right, because we explained all that stuff. How many triangles am I going to get out of that? 5, exactly right. 5 triangles. And that's going to be 5 times what? 180 equals, I don't know what that is off the top of my head. What is that? What's 180 plus that? 900? Is that right? Anybody got a calculator? Because I'm going to need you. You got a calculator out? All right. Let's jump up. Let's go to the next one, because the next one's a very familiar type of polygon, isn't it? It's an octagon. Okay, so if I have an octagon, that's 8 sides. So how many triangles am I going to get? 6 triangles. So it's going to be 6 times 180. What's that? 1080 or something like that? Yeah. Yep, 1080. Yeah, because 180, that's 1,080, 1080. Good. Do you see a pattern developing? You should by now, all right? So if you have, now watch this. Instead of giving you a number, we're going to do a little bit of algebra stuff because letters stand for numbers, right? So I'm going to call it n sides. Okay? So what if I have n number of sides? N could stand for anything. How many triangles am I going to get if I have n number of sides? Look at it. I went 4 to 2. I went 5 to 3. I went 6 to 4. I went 7 to 5. I went 8 to 6. What did I do every single time? I subtracted 2, so it's going to be what, Hunter? N minus 2, right. So I'm going to have n minus 2, what? Triangles. Agreed? I should put apostrophe S on all of these, but I didn't. So what's my little formula? It's n minus 2 times what? 180. So that's the theorem right there. We developed it on our own, didn't we? Right? We didn't have to, I could have just started class and saying, okay, this is how you find the sum of the angles of any convex polygon. Take how many sides you have, subtract 2 from it, and then multiply it by 180. And you'd be able to get the answer to these problems, all right? But that wouldn't be as fun, was it? Just giving you the formula? No, I think it was kind of cool to see that we developed it ourselves, and so if you forget it, it kind of helps. So here's what the formula basically says. The sum of any convex polygon some of the angles, I should have said that. The sum of the angles of any convex polygon is equal to what? N, what? Minus 2.
Angle sum?
The angle sum. The sum of the angles. The angle sum. All right, if you want to put angle in front of sum, that's fine. Okay, or the sum of the angles of a convex polygon is n minus 2 times 180 degrees. That is the formula that you need to know. And hopefully you should be able to remember it, all right? You come back to this time, right, and you're like, oh yeah, I remember he drew all those pictures, we drew the diagonals, and then we kind of found we found the pattern that was going on, and we came up with that little formula. So it's not something I just threw out at you and said, memorize it, believe me, and then let's move on, okay? We showed you actually how you got that, which I think is kind of cool, don't you? Yeah, I think so. All right. So now what we're going to do is we are going to go a little bit more specific. Okay, instead of just any old convex polygon, what we're going to do is talk about a regular. I'm not going to write convex on here, just make the assumption that we're always going to do convex, okay? And plus, if it's going to be a regular polygon, it can't be concave anyway. It's always got to be convex. So a regular polygon. So what do we know about a regular polygon? It's supposed to be an O. What do you know about a regular polygon? We've discussed this before. What's a regular polygon have? What's congruent sides and something else? Congruent angles, exactly right. So a regular polygon, all the angles are equal to each other and all the what? Sides are equal to each other. So this little program right here, if I go to polygon, it will actually give me, it starts off at 6, so we'll get it 6. It gives me a regular polygon. Now, I could change the shape a little bit by going like this. Would that be a regular polygon now? No, because all the sides are not equal to each other, and all the angles are definitely not equal to each other. But if I start here on this program, I have to hit Shift to keep it in proportion. So what's true about this? This is a what? A regular polygon. More specifically, it's a regular what? Hexagon, or 6 sides, okay? What I want us to do is we are going to figure out, I didn't give you any numbers at all, right? Except I said that there's 6 sides, right? I didn't really give it to you. You can look at it, you can count it, you can see 6 sides, right? Since all the angles are equal to each other, and you know all the sides are equal to each other as well, I'm not even going to mark those. I'm just worried about the angles right now. Well, I'm not worried about them. I just want to know something. I want to learn something about these angles. Since all those angles are exactly equal to each other, you should be able to tell me what each of those angles are equal to just with that information. How would you do it? Nobody? Well, what did we just finish doing? We found out the angle sum, didn't we? So all of these angles add up to what? Look at your notes. We got it written down. 6-sided figure, hexagon. What was the angle sum of a hexagon? 720, right? It was 720 degrees, all right? So if I added up all these angles, let's call this angle X. Is that all right? All right, we don't usually put like an X inside of here to represent the angle, but that's like X degrees, the measure of the angle, all right? So if that's X degrees, that's X, 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 and X. Everybody with me? How many X's do I have? I got 6, and they're all exactly the same, right? So what if I wanted to find the sum of all those angles? It's 6 times what?
6 times...
How many angles? I got 6 angles. What's each angle equal to? X. So it's 6x. Would you agree? So the sum of all these angles is 6x. So 6x equals what? 720. Okay? How do I find each of those angles? Just divide by 6. Exactly right. Divide this by 6. Divide this by 6. You kidding me? So what is that? 120 degrees. So that is the angle sum. All right, now I got to pause this. Do I know how to pause this? All right, everybody, you got to go. I got to figure out how to pause this. Where is the pause button? Do you see it? Where does it say stop recording? Oh, pause button right there. All right. Now we're good. See, that didn't take long at all, did it? All right. So where were we? Okay. So regular polygon, right? So if it's 720, you divide by how many angles you have, right? Which would be the same number of how many sides you have. Okay. Number of sides equals the same thing as the number of angles. All right. So let's come up with a little formula for that. So how would I find? We'll call it this. How do I find what each interior, right? That's what each of these angles are. They're interior angles. So how do I find each interior angle of a regular? This only works when it's a regular, okay? When all the angles are exactly the same. A regular polygon. So what if I was given the number of sides, okay? So what if I was given the number of sides, n, and I asked you to find each angle of that regular polygon? What would you do first? You'd do what? Well, you'd find the sum of the angles first, right? Like we did on that other one, 720. How did we get 720? We went n minus 2. Whoops, daisy. N minus 2 times what? Times 180. And then divided by what? N, right, the number of sides that you have, right? So right there, That's each interior angle of a regular polygon. So let's put it into practice. Let's do one we haven't done yet. Let's go 10 sides. Who's got a calculator on them? Okay, get a calculator out. Here, I got one right here. Just use this one. Use that one right there. Okay. Oh, you broke my calculator. Right, it's not 10 times 180. So, what number are we going to put? Let's put all the numbers in, okay, instead of doing it in our head. So it's n minus 2, so it's what? 10 minus 2, correct? Times what? 180, and then we do what to it? Divide it by 10. That's right, divide it by 10. So 10 minus 2 is 8, so it's 8 times 180 divided by 10. So what's 8 times 180? 1440, okay. 1440, divide that by 10. That math is really easy now. What's that? 144. So if you have a decagon, right, a 10-sided regular decagon, this only works when they're regular, okay? Each angle of a regular decagon is 144 degrees, all right? Let's do a couple ones that we're a little more familiar with. We probably see an octagon every single day if you leave the house. If you leave the house and you get in a car, most likely you will see one of these. What is it? It's a stop sign, all right? So how many sides does a stop sign have? 8. So let's do that. So it's 8, it's 8 minus 2 times what? 180 divided by 8. Let's do the math on that. That's 6 times 180. And that's what? What did we say in 8-sided? Oh, we haven't done 8-sided yet. What's 108? Calculator man, what's 180 times 6? 1080? Yeah, I should know these. These are all familiar when I see the numbers, but I forget which one's which. And then divide that by 8, and I think I know what this is. Isn't that 135? Did you do it? Put it in a calculator just so we see. 1080 divided by 8. I think it's 135. Quick.
Yeah, 135.
Why is it taking so long? Is it 135? Okay, good. I was pretty sure it was. I do have some of these memorized. I should have them a little bit more memorized, but I only do this once a year, so I can't remember. So anyway, it's 135 degrees. So if you happen, now I wouldn't advise this, but if you happen to drive by and you have like a little protractor with you, you could always jump out, right, and say, wait a minute, Mom, hang on. I got to find out if Mr. Hamrick was right. I'm kind of being silly. All right, but you jump out, you put your protractor up against one of the angles of the stop sign, and guess what it's going to be? It's going to be 135 degrees. All right? So there you go. All right? Everybody with me on that? All right, let's do an example, and then we still are not going to quite finish. We would have been able to finish if we didn't have that fire drill. Yeah, we got 2 minutes. Let me try to get as much of this done as I can. So I'm going to draw a quadrilateral. And it's probably, not probably, it definitely will not be to scale, but that's okay. Let's just throw some numbers in there. Let's say that's 73 degrees. Let's say that's 115 degrees. Let's say this is 105. And let's say this is 67. That should add up to 180 because I'm looking at my notes and I think they do add up to 180. What I want to do is this. Now watch very carefully what I'm going to do. Don't back up. All right? I'm going to extend each of the sides of the quadrilateral. So I'm going to extend that side. I'm going to extend this one. I'm going to take this one. I'm going to extend it. And I'm going to take this one. And I'm going to extend that. All right, calculator boy. You ready? Punch numbers in faster than you did before. What's 180 minus 115? Should know that already. Isn't that 65? Yeah. So that would be 65 degrees. All right. I got this in my notes. I'll just write it down since time is fleeting. So that's 107. This is 75. I'm not just making these numbers up. I'm figuring them out, correct? All right, because I just subtract from 180. Agreed? Now, this is what's really cool about this, and we'll end with this. All right, Connor, add them up. 60, all the pink ones. 65 plus 75 plus 113 plus 107. And these are all what? What are these pink ones? They're not interior angles. What are they? They're exterior angles.
360.
That's exactly right. They add up to 360 degrees. What's really cool about this, I did a quadrilateral, right? I could also do this with a pentagon, with a hexagon, with an octagon, with a decagon, any side. So listen. Any polygon. It does not matter how many sides your polygon has, if it's a convex polygon. All the exterior angles will always equal the same number. And what is that number? 360 degrees. So here's what I want you to do for homework. I want you to do 19 to 34, and you should be able to do all of those, okay? So it's 19 to 34. It's page 253. All right, you can go. I gave you a lesson plan thing anyway, so there you go. So we'll go over all of that, 1 to 34 tomorrow, okay?